Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, I'd like to remind our amazing listeners to rate our podcast on whatever platform you're tuning in from. Your feedback helps us grow and improve the show.
Absolutely, Sheila, and we truly appreciate every single listener out there. Now, let's get into today's topic. We're continuing our journey through Season 2, focusing on core hole-punch technologies. We're in Chapter 2, which is all about Hyperswarm networking, and today we'll be discussing a crucial aspect: establishing connections.
That's right, Victor. And to kick things off, I've got a brain teaser for our listeners. Here's the quiz question. What common household appliance shares a key characteristic with the challenge of establishing peer-to-peer connections over the internet?
Ooh, that's an intriguing question, Sheila. It really makes you think about the everyday objects around us and how they might relate to complex networking concepts. I'm curious to see if our listeners can draw the connection. Without giving away the answer, I think this question will help us understand a fundamental challenge in P2P networking.
Exactly. Now, before we delve deeper, let's clarify some key terms for our listeners. Victor, could you briefly explain what we mean by establishing connections in the context of Hyperswarm?
Certainly, Sheila. In Hyperswarm, establishing connections refers to the process of creating a direct link between two peers in the network. This allows them to communicate and share data directly, without relying on a central server. It's a crucial step in building a decentralized network.
Thanks, Victor. Now, let's start from the beginning. Can you walk us through the basic process of how Hyperswarm establishes connections between peers?
Of course, Sheila. The process begins when one peer wants to connect to another. First, they need to discover each other's network addresses, which we covered in our previous episode on peer discovery. Once they have this information, they attempt to establish a direct connection.
That sounds straightforward, but I imagine it's not always that simple in practice. What kind of challenges does Hyperswarm face when trying to establish these connections?
You're absolutely right, Sheila. One of the biggest challenges is something called NAT traversal. NAT stands for Network Address Translation, and it's a technique used by routers to allow multiple devices on a local network to share a single public IP address.
I think I see where this is going. Is this related to our quiz question? The household appliance that shares a characteristic with P2P connection challenges.
You're on the right track, Sheila. NAT is indeed related to our quiz question. Just like how NAT can make it difficult for external connections to reach devices on a local network, our mystery household appliance creates a similar barrier. But let's not give away too much just yet.
Fair enough. So, how does Hyperswarm deal with this NAT traversal challenge?
Hyperswarm employs several techniques to overcome NAT traversal. One of the primary methods is called hole punching. This involves both peers sending packets to each other simultaneously, which can create temporary openings in their respective NATs.
That's fascinating. It's almost like they're playing a coordinated game to outsmart the NAT. Can you elaborate on how this hole-punching process works?
Absolutely. Imagine you and a friend are trying to meet in a crowded place. You both agree to wave your hands at exactly 2 p.m. When you do this, you create a moment where you can spot each other despite the crowd. Hole punching works similarly. Both peers send packets at an agreed time, creating a brief window where their NATs allow the connection.
That's a great analogy, Victor. It really helps visualize the process. Now, once the connection is established, what happens next? Is there some kind of handshake or authentication process?
Indeed there is, Sheila. Once the initial connection is made, Hyperswarm performs a handshake. This involves exchanging cryptographic keys to verify the identity of each peer and to set up encrypted communication. This step is crucial for ensuring the security and integrity of the connection.
Security is definitely important in a decentralized network. Speaking of which, what kind of encryption does Hyperswarm use for these connections?
Hyperswarm uses state-of-the-art encryption protocols. By default, it employs noise, a modern cryptographic protocol framework. This provides strong encryption and perfect forward secrecy, meaning that even if a key is compromised in the future, past communications remain secure.
That's impressive, Victor. It seems like Hyperswarm has really thought through the security aspects. Now, I'm curious about how this compares to other P2P technologies. Are there any significant differences in how Hyperswarm establishes connections compared to, say, BitTorrent?
Great question, Sheila. While the basic principles are similar, Hyperswarm has some unique features. For instance, it uses a distributed hash table, or DHT, for peer discovery, which is more efficient than BitTorrent's tracker-based system. A DHT is like a decentralized phone book that helps peers find each other. Additionally, Hyperswarm is designed to be more versatile, allowing for various types of P2P applications beyond just file sharing.
That makes sense. It sounds like Hyperswarm is built to be a more general-purpose P2P networking solution. Are there any common pitfalls or misunderstandings that developers should be aware of when working with Hyperswarm connections?
Absolutely, Sheila. One common misunderstanding is assuming that all connections will be direct peer-to-peer. In reality, sometimes NAT traversal fails, and Hyperswarm might need to resort to relay servers to establish a connection. Developers should be prepared to handle these scenarios gracefully.
That's a valuable point, Victor. It's important to design applications with these potential limitations in mind. Do you have any tips or best practices for developers working with Hyperswarm connections?
Certainly, one key tip is to implement proper error handling and retry mechanisms. P2P connections can be unpredictable, so your application should be resilient to connection failures. Also, it's a good idea to provide feedback to users about the connection status, as P2P connections might take longer to establish than traditional client-server connections.
Those are great tips, Victor. Now, before we wrap up, I think it's time to reveal the answer to our quiz question. What household appliance shares a key characteristic with the challenge of establishing P2P connections?
Ah yes, the moment of truth. The answer is a router. Just like how a NAT in a router can make it challenging for external connections to reach devices on a local network, establishing P2P connections often involves overcoming similar barriers. Both scenarios require special techniques to allow communication between the inside and outside world.
That's a clever connection. I hope our listeners found that as interesting as I did. Now let's summarize the main points we've covered today about establishing connections in Hyperswarm.
Great idea, Sheila. Here are the key takeaways. 1. Establishing connections in Hyperswarm involves peer discovery and direct connection attempts. 2. NAT traversal is a major challenge, often addressed through techniques like hole punching. 3. Once connected, peers perform a cryptographic handshake for authentication and set up encrypted communication. 4. Hyperswarm uses modern encryption protocols like noise for secure connections. 5. Developers should be prepared to handle scenarios where direct P2P connections aren't possible and implement proper error handling.
Excellent summary, Victor. And to our listeners, remember that understanding these concepts is crucial for building robust, decentralized applications. We hope you found this episode informative and engaging. If you did, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon also goes a long way in helping us create more content like this. Don't forget to subscribe and rate our podcast. It really helps us reach more developers interested in decentralized technologies.
Absolutely, Sheila. Your engagement means the world to us. We'll be back soon with more insights into the fascinating world of decentralized application development. Until then, happy coding, everyone.